As we begin to explore this new section here, we start off with a new idea of the difference of a cosine angle and what it splits on up to be, or how we could use it. So we have this new identity that the cosine of alpha minus beta equals the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. And what that kind of means in this case here a little bit is that imagine I have two angles here. And I have this one angle measured as beta, as designated by that ray, and I have another ray over here designated by an angle of alpha. So the question I'm asking is well, what's the measurement of the angle that's in between that, of alpha minus beta, which is listed here in red? And so on our last section, we were able to learn some of how to use our trig identities to verify one side equaling the other side. And we could do that with a very long proof. That's fascinating, but I don't have enough space on my whiteboard behind me to do that. So if you're really interested, maybe I'll post a video later, or you can go ahead and Google that at some point in time. So how does this help us? How can we use this right now? Well, let's look at this one example that I have here of the cosine of 15 degrees. And I want to find its exact measurement. Well, cosine of 15 wasn't one of those major ones that I knew, or one of the major ones that we were trying to commit to our memory. So maybe I can rethink of 15 degrees as a difference of two other numbers that I am more familiar with. So for example, I can rewrite cosine of 15 degrees as the cosine of 60 minus 45. And both cosines of 45s and cosines of 60s I'm a little familiar with. So if I look at this model that I have here, I can rewrite that as the cosine of alpha, which is 60 degrees, times the cosine of 45 degrees, plus the sine of 60 degrees, times the sine of 45 degrees. And those are the ones that should be a little bit more familiar with me. So the cosine of 60 degrees was 1/2. The cosine of 45 degrees was root 2 over 2. The sine of 60 degrees was root 3 over 2. And the sine of 45 degrees was root 2 over 2. And then from there, it's some basic algebra to go ahead and solve that. So multiply this, I have root 2 over 4. Over here, I have root 3 times root 2, which is a root 6, all over a 4. I have common denominator, so I can add those on up. So I have root 2 plus root 6 all over 4. And I can't reduce that down any further, so the exact measurement, or the exact value of the cosine of 15 degrees is root 2 plus root 6 all over 4.